Good morning, students. We are continuing with our chapter vector. Okay, so the last section is vector product. Okay, so in the previous section we have studied what are the vectors means, what does the scalars, okay, and what scalar product. What do you mean by a scalar product and their properties? How will the scalar product means? Okay, that always we have studied that all things we have studied. So in this section we have studying about the vector product. So let us start our topic. So we know about the scalar product. We have combining to scalars. So similarly vector products are combining to vectors. Okay, that we calculate vector product of two vectors. The result is the vector. Okay, the result is a vector. That means if we combine a vector with a vector, that means a vector has magnitude and direction, so we get another vector, that is with magnitude and direction. We know for a scalar product, we know two scalars have been combined, then we get a scalar. That means it has only magnitude, no direction. So if we combine two vectors, we get a vector. So that is a vector. And geometrically, the definition of a vector is, look at the figure given. Yes, two vectors, vector A and vector B has been given, and the two vectors have the same endpoint. Okay, same endpoint, and the angle is labeled there, theta. Theta is the angle between vector A and vector B, and these two vectors have the same endpoint. Then the modulus or magnitude of the vector is modulus of A. Okay, modulus of vector A into modulus of vector B into sine theta. So in case of scalar product, we have taking the cos of the angle, but in vector we have taking the sine of the angle. So the vector product of A and B is defined to be A cross B. Okay, A cross B. Vector product is A cross B. What is the scalar product? A dot B. So vector product is read as A cross B is equal to modulus of A into modulus of B into sine theta into n cap. What is n cap? Yes, it is the unit vector. It is the unit vector. So modulus of A is the magnitude of A, modulus of B is the magnitude of B, and theta is the angle between A and B, and n is the, yes, n cap is the unit vector. Okay, so this is the vector product. Okay, yes. And next is some properties of vector products. Some properties has been given. Is two vectors has been combined, we can calculate the product in different order, that is B cross A. We can find also B cross A using the definition of B cross A. What is A cross B is vector modulus of A into modulus of B into sine theta. Then what is B cross A? Modulus of B into modulus of A into sine theta into n cap, unit vector. Okay, that is the direction of B cross A is opposite to that of A cross B. That is the only change. And so the vector product is commutative, and it is distributive over addition. Okay, this means A cross B plus C is equal to A cross B plus B cross C, and also the reverse. Okay, so that is given. And if two vectors are parallel, then A cross B is 0, and for vector A is equal to a1i plus a2j plus a3k, and B is b1i plus b2j plus b3k. We have A cross B is a2b3 into a3b2 I plus a3b1 into a1b3 into j plus a1b2 into a2b1 into k. This is the some properties of vector product. And the geometric interpretation of vector product has been given. Okay, look at that figure. As vector A and vector B is drawn, and theta is the angle. Then if we extend x-axis and the vector A and vector B, we get a parallelogram there. Okay, so OA, here vector OA is vector A and vector OB is vector B. Then these are non-parallel lines. Non-null vectors means it is not null vector, it is not zero, it is a non-zero vectors. And the theta is the angle between OA and OB. And A is modulus of A, that means the magnitude of vector A, and B is magnitude of vector B. Then by definition we know AB sin theta into n cap. Then we take the magnitude, then we get, yes. So we are completing that parallelogram, extending that to vectors, we get the parallelogram. Then the area of the parallelogram is, yes, 2 into area of OAB. OAB. Triangle OAB. If we draw a triangle, okay, so we get the answer. That is, vector A cross vector B is a vector perpendicular to both vector A and vector B, whose magnitude is equal to the area of the parallelogram, whose adjacent sides are vectors vector A and vector B. So geometrically we can say the cross product, that means the vector product of a vector, it is perpendicular to the magnitude, okay, whose perpendicular to vector A and B, and that magnitude A cross B is equal to the area of the parallelogram. What is the case here? Yes, the sides must be vector A and vector B. Okay, that is the geometrical representation. And some another results has been given. Vector two products, yes, the vector product of two parallel or collinear vectors is 0, and vector A cross vector A is 0, and that is some results. And next is also vector product of two perpendicular vectors. I will define that. And vector product of two unit vectors, and vector product of unit vectors I cap, j cap and k cap. Okay, that is. And also expressed as determinant. Okay, you have studied about determinant, so how will you represent it as a determinant? Vector A, vector B is given, and A cross B is find there. So A2 B3 minus A3 B2, that is, we have in the properties we have the last property is this, and then from that we have converting it as a determinant. It is easy, it will get it easy for you, okay, for doing problems. And non-zero and non-linear vectors, how will you find the angle sin theta? How will you find sin theta? It is from the from the definition itself we can find it, okay. And vector area of plane region, okay, vector area of plane region bounded by a closed curve, that is also given there, okay. That is the closed curve, that is in the anti-clockwise direction. You have to, yes, consider this boundary of the closed curve, and the direction P1, P2, P3 is in anti-clockwise with respect to the point P1, and the direction of the curve P1, okay, P1, P3, P2 is clockwise with respect to P1. Look at that figure, you will get, yes, the direction is given there, okay. And A, look at A, yes, it is a plane area, and that is bounded by, that region is bounded by P1, P2, P3, or P1, P3, P2, that is, okay. And we have associated with the unit vector n cap also. That unit vector n cap, look at there from P1, okay, we have drawn perpendicular to that, is in the anti-clockwise direction also. And if the direction of the curve is anti-clockwise, then P1, P2, P1, P2, okay, P1, P2, P1, P3, okay, and n cap, these form a vector triad. That means these two vectors have in the same direction, okay. Oh yes, in a right hand system means it is in the same direction, okay. And A n cap, A is the region n cap, that is the vector area, okay, that is bounded by closed curve P1, P2, P3, P1, P2, P3, okay, that is enclosed by this curve. A is enclosed by this curve, then A into n cap is the vector area of that plane region, okay. And if the direction is if P1, P3, P1 P2. Look at P1 P3 and P1 P2. Okay, and minus n cap. Next figure, minus n cap means it is in the opposite direction. N cap is in the opposite direction, so it is minus n cap. Then A into minus n cap is the vector area of the vector area. It is the of that plane region. It is the vector area of that plane region. Okay, these two are the vector areas of plane region which was enclosed, which was bounded by a closed curve. Okay, this two closed curve has been given. So if the n cap is in the positive direction and the negative direction has been changing, what will get there? Okay, yes, this is the vector area. And next is the vector area of a triangle. Okay, that is given there. You need not need to yes, proof, the proof is not important, but the 2 points are very important. The vector area of a triangle ABC is equal to 1 by 2 into vector AB in cross vector AC, and the vector area of a triangle ABC with vertices has been given, having yes, a vector A, vector B and vector C, yes, respectively, which is 1 by 2 vector B cross vector C plus vector C cross vector A plus vector A cross vector B. Okay, these are the two area of vector area of triangles. We have given, yes, that if the vertices has been given or another case. And some exercises. Okay, using these properties you have to do these exercises. Okay, so this is the today's class. So please go through this. This is the last section of this chapter. Okay, so vectors are I think all of you understood this. It is lengthy, but it is easy. So if you have any problem in understanding any section, please ask me. I will correct it. Okay, and please do the exercises also. Okay, thank you, students.